Okay, now we're going to look at quadratic equations. So we're looking at y, in this case, y equals x2, right? X squared, I'm sorry, right now. X squared. So you see that because it's quadratic, it's got this curve shape, and I've left the absolute value equation back there in the background just so we can see how they act sort of the same. So if you see how absolute value changes given the various parameters, you'll see how the quadratic equation does also. So y equals x squared is where it is. Y equals x squared is where it's at now, and we'll take a look at this point, and that'll just show us that the values are what you expect, right? So at negative 1 squared is 1, negative 2 squared is 4, and there's our negative 1 squared is 1, and 1 squared is 1, and if we go up here, then we know that, and here's 2 squared is 4. Okay, so that's y equals x squared, okay, as we would expect. Now, what we're going to do is we're going to, down below here I have a version of the equation where we can make some adjustments just like we did with the absolute value. So we're going to add something. You see how similar these look over here, okay? Just like we have the x plus a value in there, we're gonna see what happens when we change that what we're adding to x inside of the parentheses. So essentially this equation is y equals x squared, but now it's y equals x plus 1.5 squared, y equals x plus 1.8 squared, and you can see what's happening when we add those numbers in. Just like with the absolute value. See, the absolute value is doing the same thing, just like we saw before. If we add 3 inside the parentheses there, x plus 3 squared, then we move over 3 to the left, okay? That has to do with the fact that if in this case if x is negative 3 plus 3 is 0, and so y comes out to be 0. And now if we have, if x is 2, so 2 plus a negative 2, over here, 2 plus negative 2 is 0, so we know the vertex is going to be at 2 comma 0, okay? Now let's put it back in the center. Now let's see what happens. What we would expect, remember when we changed the slope value for the absolute value, that it changed sort of the slope of the line coming in and out, okay? Now what happens if we change this value, the coefficient out here? Well, I would expect that if we made that number bigger, if we made a number bigger for the absolute value, it made the line steeper, right? Just like we would expect. Well, if we make the coefficient greater, then let's see what happens. One might expect that the curve would get tighter and sort of smaller. So let's see what happens. Narrower, and there it is. See how it sort of echoes what happens with the absolute value. So by increasing the coefficient, we can make the parabola, which is the shape that we're looking at here, smaller. And by decreasing it, you see how we make it sort of wider, okay? So that controls the shape of the quadratic equation. And I would encourage you to try this out. Now let's take a look here. So now we make a negative. Now here's where it gets different than the absolute value. Negative, because the coefficient's sort of on the outside of the squared, it actually will flip over the parabola, okay? In the case of the absolute value, the coefficient, or the slope there, was inside the absolute value, so it stayed above 0. Now it's outside the squared, so it will actually cause the values to go negative, okay? So we know that, for example, when x equals 1, 1 squared is 1, and 1 times a negative 1 is a negative 1, so y will equal negative 1. That's a lot of numbers coming by there, but if you try it yourself, you should try it yourself and see that this is the case. One last thing, just like we did for the absolute value, let's see what happens when we have this added on constant or number on the outside of the squared term. And like absolute value, remember we moved up and down the y-axis, and look, same thing happens with the parabola. So if we want to, if our parabola is above the x-axis, then we know that we are adding on a positive value, and if it's below, we're adding on a negative value. Same thing.